Hey there, Internet! Keeve here, and welcome to the Cars and Keeve YouTube channel. It's been a minute since we did a DI system test, so I picked up the Griot's Garage DI Spotless system, or Grios, whatever you want to say. Until they make an electric foamer that works with the crap, I'll call it whatever I want. It's about $299 on their website. It's really not available anywhere else, not available on Amazon, only at Griot's Garage. Now, they don't have like any affiliate or anything like that, so I'll link their website below. This size, the Spot Buy, which is a video I did some time ago, Amazon, you see the difference in the size of the tank. This is roughly 2 times the size of this one, so 2 times the capacity. Not only does that give you twice the amount of time on your resin, but gives you more gallons per minute because the Griots can do 4 gallons per minute. They have really nice built-in bypass. And this has way more capacity than they give you. They only give you 13 pounds of resin, or they say there's 13 pounds of resin. We're going to weigh that to make sure. Or you could add to this capacity with some Colombian Bam Bam.
What the hell are you talking about?
Cops are coming. There's a kilo of Colombian Bam Bam under the car.
Now, many of you may know this. These are about 50 bucks on Amazon, and it gets 8 pounds of resin. That comes out to about $265 for a cubic foot. When you can buy them in individual packages like this, sealed up, you know, you don't have to worry about getting a bulk box, opening it up, filling it up, and then leaving the rest, hoping that it doesn't go bad before you get to it. On the back, it actually says what it is at 4 gallons per minute, at 50 parts per million, 1,410 gallons, 100 ppm, 705. Whether you got well water, whether you got city water, every city, every county treats their water differently. They use chloramines, they use chlorine. Some use more chlorine than others. Some have more residual chlorine out the back end than others do. Chlorine eats resin. If you have well water, CO2, traps CO2 in the water, it eats resin as well. So my 50 to 60 ppm water actually works more like off this chart, like 100 ppm water. Like on a CR Spotless, it says you can get well over 1,000 gallons. I get 700 to 800 gallons. And that's more of their 100 ppm equivalent, which I'm thinking here when we do this, I'm going to get about 700 to 800 gallons. Basically, as you double the ppm, you cut the gallons in half each time. And these are really easy to put on. They're almost like union joints. And you have your bypass. So the inlet is here on the left. So if you're facing the unit, facing this way, this is the input. And they have nice little arrows here. So this is in bypass mode. So in bypass mode, the arrows go towards each other. So it goes here, runs across this little tube that runs between these, comes out, and then goes out the output that way. So if you want to have it filter, you have it go up. But if you want it filtered, but you just want to come over here and turn the water off, you can turn this sideways. It's going to go in, but it's not going to come out. Then if you want it to come out, you do just like that. So the water coming in this way, arrow goes down all the way down to the bottom of the tank, comes back up through the pipe in the middle, comes out the outside, out this arrow, and out. These right here are also just these little hand-tight union joints as well for your output. Now here's a problem that I have with this. These are 3/4 MPT threads. They give you a hose on both sides, nice little swivel, you know, handmade hose with a crimp, but those are garden hose threads. These do not match up, but yet in their pictures they show this hose being connected to this thread. These do not go together. So up close, this is what I mean by the difference between MPT and GHT. MPT at the bottom, national pipe thread, and it's tapered. The top is 3/4 garden hose thread. This is what all your garden hoses and everything that you normally use connects with here. See how the threadings are spread further apart and the threads are thicker. These are much smaller. They're more mechanical in nature and how they screw pattern. But that is what is at the end of this Griots, and that does not hook up to a water hose. Now let's show you inside of this. Now this is screwed on, and tight is pretty much dead in line with their logo. So you got to get a really good grip and push this. Now I took the pipe out the middle already because it's in the resin. So that's not on here because I wanted to show you why. When you remove this at any point in time, take this tube out because sometimes it gets stuck in there because you can see at the end, this filter piece sits way down at the bottom down here. The water comes in, it travels through all of that resin, gets all the way to the bottom. Then it rises back up through this tube. Now, if this tube is not properly seated, that water blows back out and then comes back through this filter right back in. So you're not getting the filtering that you need. You have a chance to contaminate with resin. So this goes all the way in, and you just keep going until it stops. There's a stop point that doesn't allow it to go any further, so it doesn't block the water flow. But to make sure it's all the way in there. When the resin's in there and the resin's all the way full, if you just fill it up with water to where the water's at the top of the resin, it'll be very buoyant and very easy for this to go back in. You really don't want to put these in with just resin all packed up in there. It's much harder to do it that way. It's much easier to do when it's wet. Now, I don't know if you can see this line right here, but right here is where the resin is. Shook it a few times, so the resin's still about right here. I think easily we could fit 8 more pounds, if not more, in here. And that's going to put it at almost a half a cubic foot, because a cubic foot's about 42 to 43 pounds. And that would definitely increase these numbers a good bit and make it much longer between your resin refills, and also allow you to flow maybe a little bit more water because you have much more surface area for it to filter. So you can see that grain of resin right there? So you can see it's just large enough to not fit through this slit. Oh, and by the way, the Colombian Bam Bam weighs 3.63 kilos, 8 pounds. So I'm going to put a bucket here. We'll tear it out. We're at 0. So when we turn this upside down, our resin is going to come out, and hopefully it's 13 pounds. Well, it's not that bad, 12.34 pounds. So we're close to the 13. I don't consider that bad off. That's going to be fun putting it back. So I highly recommend one of these. This is basically just a food funnel. I'll link it below. They're like just a couple of dollars. But one thing you want to do first is get you a brush, whatever kind of brush you can find, and just work all the resin that's in there out of the threads. So make sure the pipe is fully seated in there. Now we have that water. I actually filled it up a little bit higher to make it a little more buoyant, because we are going to have to work this a little bit because there is a lot of resin in there. But by having the water in there, we're going to be able to move this around, and that's going to allow this to move down. Just got to keep working down till we get to the threads. There we go. I think it's time to put some water through this. So check out the links below for anything in the video. Don't forget to like, comment, subscribe. Let's get testing. My wall setup is gone. This is all taken off to be a part of a video that I had to delay a week or two, so now I don't have a DI system on the wall. I have the water coming directly out of the wall to my Blue Seal retractable reel, to my Flexzilla hose, my Elay quick connect. Just take that off. So I'll take my hose, I hook it up to the input side. The good thing is since this is kind of heavy, and this is free flowing, so this doesn't it's not fixed, so it rocks to the position that it's at, so it's not putting any strain on any of the connections. And we have our output here. I think I'm going to kind of do this because that way I'll be able to see my gallons per minute better. This right here is my hose. It goes outside to a water bladder. That water bladder holds 500 gallons, so we don't try to waste water if we can. Obviously, it's going to do more than 500. Once I fill that up, I will have to dump the rest out into the woods. I want to check the flow of the bypass right now. 7 gallons per minute. Now we're going to judge the water going through the bypass, the TDS. I have my TDS meter here. This is from HM Digital. This is a calibrated one. I have solution, 342 part per million solution. This measured 350, so it's really, really accurate right now. We are dead on 50, so our water is actually pretty good right now. So now we're gonna turn on the flow through the filter. I'm gonna run it for a good 5 minutes to get everything all flushed out, nice and going. It's coming out 6 gallons per minute. I'm gonna turn my water back a little bit. 4.0 gallons per minute. We're gonna let that run for 5 minutes. All right, it's been 5 minutes. I'm gonna capture some water. Turn that off so we don't waste. So there you go, 0 ppm. Now this is way too much water and way too much time to be doing time lapse. We're talking 4 or 5 hours worth here probably. Let me flow my water. 4 gallons per minute. We're just gonna let that run for hours. So here we are up close. You can see we are running 4.0 gallons per minute. So far, we have run about 17 gallons. And all the way out here is my bladder. So I kind of have it hidden away. Usually I have it on the other side of the garage, but this is much better. It's going to grow much larger than this, like 3 foot tall. It's going to push it on each side, I think almost 2 feet and out the back. This should be enough room for it. And look at that. Giraffe Tools. Mr. Giraffe made a pretty good unit, even though I don't know who Mr. Giraffe is. All right, we just crossed 100 gallons. Check this out. 0 ppm. All right, we're checking. I keep forgetting it's 4 gallons per minute, so that stuff adds up fast. We're at 267 gallons. We are still currently running 4.2 gallons per minute. All right, let's check 1 ppm. Well, that's a little bit earlier than I thought. We're at about 275 gallons or so now. We'll keep an eye on it. We're going to run all the way up to 10. That's when you should start ordering your resin refill. Oh, she's getting big now. It's kind of weird that this can hold almost twice what's already in there. As you see, we still got a lot of pillowing to do. Okay, we are now at 405 gallons. I'm going to take it from the bladder outside because I want to show you something, because I think we may be off on our count a little bit. I think that meter at 4 gallons per minute is exponentially off. And this is what I'm talking about. We're at 405 gallons on the meter, but yet my 500 gallon bladder is full and overflowing. Now, obviously we're on a slight, angle here. So I can't fit exactly 500 because we're overflowing, but that is definitely not 100 gallons worth difference. And now we are running the water down to my pine straw into the woods. So we're at 5. So we were at 260 something and we had 1 ppm. We went to 5, but we're at well over 400. So the rise is less, and we'll calculate in a minute how bad it is calibration wise on that monitor. Ticking at 500 gallons. Now I believe that this is closer to 600 gallons because I just think those numbers are not quite jiving. Grab the sample from the hose just before that, and we are at 9 ppm. So we are right now about where we need to stop, but I actually want to slow this down a little bit and see what the ppm is if I slow it down to 2 gallons per minute. All right, let's see if this improves. It did. So you see the resin has more time to work. So now it's 7 versus 9. Okay, so what I'm doing now is I have the scale zeroed out with this bucket. Is it now at 0? So when I bring it back, it'll be the weight. What I'm going to do is I'm going to run this to exactly 2 gallons per minute. And then we're going to put the bucket on it, run it for a minute, and see how close we are to 2 gallons per minute. And then we're going to do it at 4 and see what the discrepancy is between the two. Because when I've done this before at 2, I was only off by like 5%. So maybe this meter has gone crazy over time. We'll have to see so we can adjust our numbers. And here we go. 25.9. That comes out to 3.1 gallons per minute. So at 2.5 gallons per minute on this monitor, it is flowing 3.1. This monitor has steadily gotten worse. I think I need to get another one. Now let's get to 4 gallons per minute. Between 4 and 4.1. We're good. 42.9, 5.14 gallons per minute. So we're off by over a gallon per minute. 23%. 23% off. But there you go. I hate that we were that inaccurate at 22.8% off, but we can adjust those numbers. In previous videos, like I said, I did check and we were really close. So I think this thing has gotten old and needs to be replaced. But what I want to do from now on is I want to check the calibration before we run and adjust back. So if I need 4 gallons per minute and I'm off by, 22.3%, then I'm going to run it at like a little over 3 gallons per minute to get it to be what 4 should be. So we can adjust it beforehand. We'll check it afterwards to see if there's a difference between the beginning and end, and that's how we'll fix accuracies in the future. I just knew when that bladder was full, I was like, wow, we're at 400. This thing's almost full. Something's not right here. But that basically puts this at 5 gallons, 5.14 gallons per minute. This thing ran, and we got 643 gallons if we adjust that 22.8%, because we got 523 comes out to 643. I actually think that's pretty good because I mentioned already that my PPM, my water at 50 plays like 100. It's the chlorine. So there you go. Don't forget to like, comment, subscribe. Don't check out the links below for anything in the video, and I'll see you in the next video. And something like... Just move this around a little bit. So I think it's time to put some water through this. So don't forget to like... I think it's time to put some water through this. I think it's time to put some water through this. Don't check. I think it's time to put some water in this. Oh shit, I'm reversing it. That was really dumb. That was really dumb because that's the input. You're an idiot.